So we need to review how to predict products. The first type of reaction I'm going to use is going to be combustion because it's an exception to all the rules. So combustion is when you have a hydrocarbon reacting with oxygen, and your products are always going to be CO2 and H2O. All right, so always the easiest to predict, always the hardest to balance. Okay, but here's your hint: always start with water. Okay, and because oxygen on this side always has to be even, right, because of the 2, this oxygen can't be odd, so the coefficient cannot be an odd number. Okay, so when I look at hydrogen here, 16, and so 2 times 8 is 16. Because this is an even number, I'm good. Now I can balance out the rest of the equation. All right, now I'm going to do 7 for 7 carbons. And so here, this is one of the places where people get it wrong. Here I have 14. Here I have 8. So 8 plus 14 is 22. Since I have 2, I need 11 diatomic oxygens to get 22. And this is balanced. Okay, so now we're going to get to the things that we need to be careful of. Okay, so let's make sure that we understand notes here. So first, in compounds, because it's ionic, in ionic compounds, cross oxidation, right? So put it here, and I'm going to label this figuring out subscripts. In elements, you look for diatomics. So again, the one that I like to use is using Gen U I. Okay, so, right, first thing we're going to do is we're going to do the chemical formula of calcium and phosphorus. Calcium does not end with gen or ine, so it's single, Ca, right? Phosphorus does not end with gen or ine, so it's going to be P. Okay? All right. So in synthesis, your single elements come together to make a compound. Right? And according to here, in ionic compounds, you cross your oxidation numbers. Calcium has a +2 charge. Phosphorus has a -3. Let me make sure on that. Sometimes I forget my oxidation numbers and I have to check. And let's see if I'm right. Pretty sure. Yes, it's a -3. Okay. Sometimes you forget if you're tired. All right. So it's going to be Ca plus P goes to Ca 3 P2 because I crossed my oxidation numbers. This is going to be easy to balance. I just need 2 phosphorus here, 3 calcium here. This brings us to a decomp reaction. So the decomposition of chromium to bromide. So first of all, we need to know the chemical formula before we decomp it. So chromium is going to be Cr. The 2 does not go on the bottom. It's not subscript. It's going to be your oxidation number. And then bromine is going to be Br -1. Right? I got to cross. This is going to be Cr, Br2. And right, we do this because we need to know the chemical formula. If you already know the chemical formula, you don't have to do this. Right? So now I'm going to split them up. right? And I'm going to split them up just like I would split some kids up if they're doing some PDA. I put my arms up and I get in between them, right? So I'm just putting in a plus sign. Okay, now I need to look for my my diatomics. Okay, chromium does not end with gen or ine, so it's not genuine. Okay, it's left alone. Bromine does end with ine, so it gets a 2. Okay, so that is chromium bromide, chromium 2 bromide decomposing into chromium and bromine. This 2 was not brought over here. It's because I checked if it was gen or ine. Okay, do not bring over your subscripts. It does not work that way most of the time. All right. Now we get to the fun stuff. Okay, so let's do barium and water. And so again, we don't worry about oxidation numbers when they're single. We're just looking for genuine, right? Barium is not genuine, so it's Ba and it's all by itself. Okay, plus water, and in this situation, you want to write water, which is H2O, as HOH. And that is because you want to be able to know how to split things up. OH is going to be an anion. C is going to be my cation, right? Or sorry, my H is going to be my cation, right? If it is easier for you to say metal and non-metal, fine. Okay? But again, this is one of those things where you replace likes with likes. Generally, if you date girls, you're going to date girls. If you date boys, you're going to date boys, right? You replace like with like. Sometimes that changes, but generally. Okay, so now I'm going to switch like with like. So because I have 2 metals, I'm going to switch my metals. I do H here, and again, because it's alone, I need to check if it's genuine. Hydrogen ends with gen, so it's going to be diatomic, and it gets a 2. And then I put Ba and OH, and now I need to check my oxidation numbers. Okay, and my oxidation number for barium is 2 plus 2. My oxidation number for hydroxide is -1, so I need to switch those. So it's going to be Ba, OH, and don't forget to use parentheses, because if you don't, then you're saying BaOH2, and that's 2 hydrogens instead of 2 hydroxide ions. Okay, so now we need to balance. Okay, so I have 1 Ba's on each side. I have 2 oxygens and 2 hydrogens here. Oh, that's right. So I'm going to put 2 here, so that I have 2 hydrogens. Whoops. There's something wrong here. Let me think about it. Oh, that's right. That's where it is. I have 4 hydrogens, because I have 2 hydrogens here and 2 hydrogens here. Okay, versus I have 2 oxygens here. So 2 times 2 here, I have 4, right? And then I have 1 oxygen here. Okay. Okay. And then finally we get to double replacement. Okay, so for double replacement, I have potassium hydroxide. Plus phosphoric acid. And I'm going to use a different bowl. So first I need to figure out the chemical formulas before I can do any kind of predicting here, right? Potassium is K, It always has an oxidation number of +1. Hydroxide is OH, right? And it's -1 because I looked at my table here. Phosphoric acid, right? It doesn't start with phosphoric. That's not the right word, but that's okay, right? And so if it has hydro, it is a binary acid. Because it doesn't have hydro in the front, I know that I need to look at my table here. So because it ends with ick, I ate something icky. So it's gonna be phosphate. So it's gonna be HPO4 -3, right? And hydrogen has a +1, right? So it's going to be KOH plus H3PO4. Okay, so again, this is the OI part of foil. So you can do it in two ways, okay? If you want to say your potassium and hydrogen switch and do arrows, you can do that. So if that is how your brain works, that is fine. And the OH and the PO4 are going to replace each other, you can say that. Or you can do it as potassium is going to link with the PO4 and H is going to get with the OH. I don't care how you connect, how you think about it. As long as you are switching partners, that's what we need to do. So potassium, the outside is going to get with the outside. It's going to be PO4. And again, this is an ionic compound, so I need to write my oxidation numbers. K plus 1, PO4 -3, plus, right, H, and I don't bring over my subscripts. And then HOH is going to be like this, right? So +1 -1 -1, right? So it's going to be K3PO4 plus, I'm going to say H2O because I find it easier to balance it that way. Actually, no, it won't. It's going to be HOH. Okay, here we go. Right, so here we go. I'm going to put 3 here. I need to put 3 here. Because I had 3 potassiums, I need 3 potassiums here. Because I have 3 hydroxides, I'm going to have 3 hydroxides here. My 3 hydrogens balance with my 3 hydrogens here. And my PO4 balances with PO4. Okay, so again, this is, if you can follow the 2 rules that I erased, which is if you're single, you have to look for diatomic and you use your genuine, or if you are in a compound, in this situation, you use your oxidation numbers. Okay, if you follow the naming rules, you will be fine. And like replaces like. That's another rule that maybe you do need to be solid on to be able to do this. But other than that, this should be simple as long as you practice. Okay? If you have any questions, let me know. I will be more than happy to help you. Have a good day. Bye.